Assalamu alaikum everyone. I hope everyone is well. So in this video I'm going to show you how you can prove mathematical facts with algebraic expressions or algebraically prove mathematical facts. So don't forget to like, subscribe and share my content. So in with the Blackboard intro. So if you go to the physics and maths tutor website and scroll down the bottom of grade 8 and 9 and the topic proof QP, if you open this in a new tab, it has a list of questions where you have to prove mathematical facts with algebra or using algebraic expressions. So if you look at the first problem, it says the nth number or the nth even number is twice n. So the next even number after twice n is twice n plus 2. You have to explain why this is the case. So if I go to my notebook and I use the pen tool, twice n. So what is twice n? Now if you notice very carefully, twice n actually yields, if I use the value of n, let's say n is 1, 2, 3, ... If I use the values of n 1, 2, 3 and use it in twice n, for 1 twice n will be what? 2, and for 2 twice n will be 4, and for 3 twice n will be 6 ... So if you notice very carefully, twice n always yields a sequence of even numbers, right? So if twice n yields a sequence of even numbers, what will be the immediate next number after twice n? It will be twice n plus 2. This is the immediate next even number after twice n. So this is what is required. You have to explain how the next even number is twice n plus 2, because twice n plus 1 is an odd number, so twice n plus 2 will be an even number. So if you look at problem B, it says write down an expression in terms of n for the next even number after twice n plus 2. So what will be after twice n plus 2? It will be twice n plus 4, because it will increase by each even number, each subsequent even number will increase by 2. So if twice n plus 2 is after twice n, then twice n plus 4 will be after twice n plus 2, or twice n plus 4 will be after, like it will be like twice n plus 2 plus 2. This is what will be the next number after twice n plus 2. So problem 1C says show algebraically that the sum of any three consecutive even numbers is always a multiple of 6. So we can algebraically express three consecutive numbers as, if I use the pen tool, if n is an even number, then the next even number is n plus 2, and the next even number after n plus 2 is n plus 4, right? These three are three consecutive even numbers. So if I sum these three consecutive even numbers, we have to show that this is a multiple of 6. So if we sum these three, n, it says 3n plus, if we add 2 and 4, it says 6. So it has 3n plus 6 is the algebraic term here. So how can you show that this is a multiple of 6? If we use factoring, we can write n plus 3 multiplied by n plus 2, which is 3n plus 6. Now we can also write this expression as what? 6 multiplied by n plus 2 divided by 2. So what is this expression? 6 into n plus 2 by 2. If we analyze this expression, for example, if you use the value of n, let's say n is an even number starting with 2. So it is 2, 4, 6, dot dot dot. So if we use the value of n here, if we start n with 2 here, if we put the value of 2, then this would be what? 2 plus 2 by 2, which is 4 by 2, which is 2. 2 multiplied by 6, 12. If we use n is 4, then it will be 4 plus 2 by 2, or 6 by 2. 3 multiplied by 6, which is 18. If we use 6 plus 2 divided by 2, or 8 divided by 2, which is 4. 4 multiplied by 6 is 24. So if we look at the series here, starting with n's value of 2 and using 2, 4, 6 dot dot dot, the series would be 12, 18, 24. These are all multiples of 6, right? So, and these are all even positive integers. So this expression will always be a multiple of 6 where n starts with 2, 4, 6 dot dot dot. So this is how we can algebraically show that this expression is a multiple of 6. Problem number 2 says prove that 3n plus 1 whole square minus 3n minus 1 whole square is a multiple of 4. So you have to show that this algebraic expression is a multiple of 4 for all positive integers values of n. So if I go to the notebook and use my pen tool, let's write 3n plus 1 whole square minus 3n minus 1 whole square minus 3n minus 1 whole square. So you have to show that this expression is a multiple of 4 for all positive values of n. So if you look closely, I can use the formula of a plus b whole square. A plus b whole square minus a minus b whole square to get another expression, or use two different formulas of a plus b whole square and a minus b whole square. So if I use this formula, a square plus twice ab plus b square minus a square plus twice ab minus minus plus twice ab minus b square. So the resultant would be what? 4ab. So this is the formula. On this expression, what will be the result? 4 multiplied by thrice n multiplied by 1. So if you look at this term, this is a multiple of 4 because there is a 4 here. So this is a multiple of 4. So if I use, for understanding, if I use the value of n as any positive, all positive integer values of n, right? It says all positive integer values. So if I use n equals 1, 2, 3 dot dot dot, for all values there will be what? If I use n1, it will be what? 12. If I use n's value 2, and 3 multiplied by 2 is 6. 6 multiplied by 4 is what? 24. Right? And if I use the value of 3, then it's 9 multiplied by 4, which is 36. So these are all multiples of 4. So you can clearly see that this expression will always yield as a multiple of 4 for all positive integer values of n. Problem number 3 says prove using algebra that the sum of two consecutive whole numbers is always an odd number. So what is the sum of two consecutive whole numbers? So if I go to my notepad and use my pen tool, let's say one number is represented by n. So what is the immediate next number after n? N plus 1, right? So the sum of two consecutive whole numbers, this expression will always be an odd number. So if we evaluate this expression, so n plus n is what? Twice n plus 1. So what is twice n? For any whole number n, twice n will always yield an even number. So if n is 1, 2, 3, ... twice n would be what? 2, 4, 6, ... So as you can see, for n, any positive number n, it will yield a even number. Twice n, expression twice n will always yield an even number. So what will the expression twice n plus 1 yield? It will yield what? If I use n1, it will be what? 3. If I use n2, it will be 5. If I use n3, it will be 7. Right? So this expression will always yield an even number. I hope you understand how I solved mathematical facts with algebra. I will make another part of this topic based on this topic, and it will cover some more problems, how I deal with mathematical facts used algebraically. So thank you for watching this video till the end.